Your dog perceives the world in a way that goes far beyond its powerful sense of smell, and in the next 13 minutes, you will discover 6 distinct senses operating within its body at this very moment. But pay close attention to the 5th, because there is real evidence that your dog might be perceiving something you hadn't even considered. Hearing. A dog's ears can pick up sounds at frequencies nearly double what yours can. High-pitched noises you'll never notice, like the ultrasonic squeak of a mouse 3 rooms away. Each ear has 18 separate muscles, letting it rotate independently to pinpoint exactly where a sound is coming from before you've even turned your head. Human hearing tops out around 20,000 hertz. A dog can hear up to 60,000 hertz, and some breeds even higher. That range overlaps with the ultrasonic calls many rodents use to communicate, which is part of why a dog can sometimes react to something moving in a wall or under the floor long before any human notices anything at all. The independent ear rotation does more than just aim toward a sound. It lets a dog compare the exact arrival time and volume of a sound between both ears, calculating direction with a precision far beyond what 2 fixed human ears could manage. A dog can typically locate the source of a sound about 4 times faster than a person can, and from a significantly greater distance. Some estimates put a dog's effective hearing range at roughly 4 times farther than a human's for the same sound. Ear shape changes this ability considerably. Upright ears, like those on a German Shepherd, act like small satellite dishes, funneling sound directly into the ear canal. Floppy ears, like those on a Basset Hound, cover the opening and dampen incoming sound, which is part of why breeds with long, heavy ears often rely more heavily on scent than on hearing to navigate the world around them. The tilted head gesture almost every dog makes toward an unfamiliar sound isn't just curiosity. It shifts the position of the outer ear enough to help the brain narrow down exactly where a sound is coming from. That sensitivity comes with a cost. Sounds that seem only mildly loud to a human, a vacuum cleaner, a smoke alarm, fireworks, can register as genuinely painful at a dog's hearing range, which is part of why sudden loud noises trigger such an extreme reaction in many dogs. It isn't an overreaction, it's an accurate response to something that actually hurts. Smell. A dog's nose contains roughly 300 million scent receptors, compared to about 6 million in a human nose. The part of a dog's brain devoted to processing smell is proportionally 40 times larger than the same region in a human brain, even though the overall dog brain is much smaller than a human one. The wet surface of a dog's nose isn't incidental. That moisture, produced by the nose itself, helps trap and dissolve scent particles from the air, making them easier for the receptors inside to detect. A dog periodically licks its own nose, partly to keep that layer of moisture fresh and functional. Dogs can also smell in something close to stereo. Each nostril takes in air and processes scent somewhat independently, which lets a dog's brain compare the concentration of a smell between the left and right side and determine which direction it's coming from, the same way 2 ears let it locate a sound. Underneath the main nasal cavity, dogs also have a second, separate smell-detecting organ called the vomeronasal organ, sometimes known as Jacobson's organ.
Dogs
it isn't connected to the same processing pathway as regular smell. It has its own dedicated nerve running directly to a different part of the brain, and it's specialized for detecting pheromones, chemical signals other animals release that carry information about reproductive status, stress, or identity. That's part of why a dog's investigative sniffing of another animal often looks different from casually smelling food. It's activating a completely separate sensory channel. A trained detection dog can pick up target scents diluted to parts per trillion, roughly equivalent to detecting a single drop of a substance dissolved into an Olympic-sized swimming pool. That capability isn't a party trick or an exaggeration. Medical detection dogs have been trained to identify certain cancers by scent alone, at accuracy rates rivaling laboratory testing, and diabetic alert dogs can detect the subtle scent shift in a person's breath that occurs minutes before a dangerous blood sugar drop, often before any device does. None of that requires special biology beyond what every dog already has. It's the same hardware, simply pointed at a specific target through training. There's also evidence that the tip of a dog's nose contains specialized nerve endings sensitive to infrared radiation, essentially faint heat, letting a dog detect the warmth radiating off a nearby warm-blooded animal, even without direct visual or scent contact. Researchers first identified this by observing dogs orienting toward heat sources too faint and too still to trigger a response through sight or smell alone, suggesting the nose may double as a low-resolution heat sensor layered on top of everything else it already does. Sight. A dog's eyes contain two types of color-detecting cells instead of the three found in typical human vision, which means dogs see a narrower range of color, closer to a red-green colorblind person than to full human color vision. Reds and greens both tend to appear as similar, muted shades of yellowish-brown. What dogs lose in color range, they gain in motion detection and low-light performance. A layer of reflective tissue behind the retina, called the tapenum lucidum, bounces light that missed the light-sensing cells back through them a second time, giving photoreceptors a second chance to catch it. That layer is also why a dog's eyes seem to glow in photos taken with a flash. As a result, most dogs can see clearly in light roughly 5 times dimmer than what a human eye needs. Dogs also have a wider field of view than humans, typically around 250 degrees depending on the breed, compared to roughly 180 degrees in people, because their eyes sit further toward the sides of their head. The trade-off is a smaller area of binocular overlap, where both eyes see the same thing at once, which slightly reduces depth perception directly in front of them compared to a human. Sighthound breeds like greyhounds and salukis take this even further, with eyes positioned to maximize peripheral motion detection, an adaptation suited to spotting fast-moving prey at a distance rather than judging fine depth close up. Their eyes are also built to catch motion faster than fine detail. A dog can detect the flicker of a moving object at a rate roughly twice as fast as a human eye can register, which is part of why a dog will often notice a thrown ball or a distant animal moving long before it notices a person standing perfectly still nearby. Whiskers. The thick hairs on a dog's muzzle, above its eyes, and near its jaw aren't ordinary fur. Each one is rooted about 3 times deeper into the skin than a regular hair, surrounded by a dense cluster of nerve endings and blood vessels that make it extraordinarily sensitive to the smallest movement. Those nerve endings mean a whisker can detect tiny changes in air currents, registering the presence of a nearby object before the dog ever makes physical contact with it. Air deflecting off a wall or a piece of furniture creates a subtle current that a whisker can pick up, which is part of how a dog navigates confidently through a dark room. The whiskers above a dog's eyes also trigger an automatic blink reflex if something brushes against them, protecting the eye from debris or injury a fraction of a second before the object would otherwise make contact. This response happens faster than conscious reaction time allows. Whiskers also send information about the size and shape of gaps and openings, letting a dog judge whether it can fit through a space before committing to it. Fewer people know that dogs also have a small cluster of shorter, stiffer whiskers on the back of each front leg, near the wrist. Those act as an early warning system while running, detecting nearby obstacles at ground level that the dog's eyes may not be angled to see. Trimming a dog's whiskers doesn't cause pain the way cutting skin would, since the hair itself has no nerve endings, but it does measurably reduce the animal's spatial awareness until they grow back in. If you've made it this far, you're probably learning something new about an animal you thought you already knew. Hit like right now. It's what gets this in front of more people who'd enjoy it. Magnetoreception. In 2013, a team of researchers tracked more than 70 dogs across 37 breeds over roughly 2 years, recording the exact compass direction each dog faced while relieving itself in open, unobstructed fields. The result wasn't random. Under calm magnetic field conditions, dogs showed a strong statistical preference for aligning their body along the north-south axis, actively avoiding an east-west orientation almost entirely. That pattern disappeared on days when the Earth's magnetic field was unstable, which ruled out simple explanations like wind direction or sun position, since neither of those factors changes based on magnetic activity. The leading explanation is that dogs, like several other animals already confirmed to have this ability, possess some form of magnetoreception, a sense that detects the Earth's magnetic field directly. Nobody has yet identified the exact biological structure responsible for it in dogs. Some researchers suspect a protein called cryptochrome, found in the eye, that reacts differently depending on magnetic field orientation. Others point to trace amounts of magnetite, a naturally magnetic mineral found in small quantities in canine tissue. This isn't unique to dogs. Migratory birds, sea turtles, and some fish are already confirmed to use magnetic fields for long-distance navigation. And in birds, the leading theory involves that same cryptochrome protein reacting to magnetic fields inside specialized cells in the eye, allowing them to essentially see the field as a visual overlay. Whether dogs process the signal in a similar way is still unknown. What makes the dog finding notable is that it suggests the sense may be far more widespread among ordinary mammals than previously assumed, quietly influencing behavior in an animal most people see every single day, without anyone realizing a magnetic compass might be involved at all. Taste. A dog's tongue has roughly 1,700 taste buds, compared to about 9,000 in a human mouth. Of all 6 senses covered here, taste is the one where a dog is measurably outmatched by a person. That doesn't mean taste is irrelevant to a dog.
Notice how a
Dogs have
dog's
taste
tongue is
receptors tuned
completely different
specifically
from
to
ours.
detect meat and
They have
fat,
special
more
receptors
sensitive
just for
than the
meat and
equivalent
fat.
human
We have those
receptors,
too. We have those
consistent with
too.
their
But to
evolutionary
them,
history as
everything tastes much
scavengers
more
and hunters.
intense.
They also have a set of receptors specifically responsive to plain water, a receptor type largely absent in humans, believed to become more active after eating salty or sugary food, encouraging the animal to rehydrate afterward. Their bitter taste receptors are also disproportionately sensitive, an inherited defense against accidentally swallowing spoiled or toxic food while scavenging, which is part of why many dogs react so strongly and immediately to bitter-tasting deterrent sprays. Much of what a dog experiences as flavor actually comes from smell, not taste. The two senses are processed together, and because a dog's sense of smell is so disproportionately powerful, it dominates the experience of eating far more than taste alone ever could. That's part of why a dog with a blocked nose, from illness or congestion, often loses interest in food almost entirely, even when nothing has actually changed about how the food tastes. None of these 6 senses stay the same throughout a dog's life. Hearing is usually the first to decline, often starting in a dog's senior years with high-frequency sounds fading before lower-pitched ones, the same pattern seen in aging human ears. Many dog owners mistake early hearing loss for stubbornness, when the dog has simply stopped receiving the command at all. The eyes change too. A bluish, cloudy haze that develops in the lens of many older dogs, called nuclear sclerosis, is often confused with cataracts, but is a normal aging change rather than a disease, and it usually causes only mild vision changes rather than blindness. True cataracts, a separate condition, can develop alongside it and cause more significant vision loss. Smell, the sense dogs rely on most, also declines with age, though more gradually than hearing or sight. The sheer number of receptors a dog starts with means even a meaningfully reduced sense of smell in an older dog often still outperforms a young human's. Taste bud count drops as well, which combined with a fading sense of smell is part of why some senior dogs become noticeably pickier, or conversely, less interested in food overall. None of these declines happen on the same schedule, or to the same degree, in every dog, but the pattern across all 6 senses is the same one seen throughout the rest of the body. Gradual wear across systems that were never built to stay static forever. 6 senses, each doing something a human sense either can't match or simply doesn't have at all. Hearing, tuned to frequencies you'll never perceive, aimed by ears that move independently of each other. Smell, powered by 300 million receptors and a second, separate organ built for reading chemical signals. Sight, trading color range for motion detection and night vision most humans could never match. Whiskers, reading air currents to sense objects before ever touching them. A possible magnetic sense, quietly aligning a dog's body to the Earth's own field. And taste, the one sense where a human actually comes out ahead. None of them work alone. Together they build a picture of the world that looks almost nothing like the one you're standing in right now. If you learned even one new thing today, subscribe, and tell me in the comments which sense surprised you the most. If this is the kind of thing that keeps you curious about the animals around you, that's exactly what this channel is about. Every animal, fully covered, one video at a time.